Now we're going to look at another way to solve a system of equations. But I'm going to give you a little bit of an example, a story for why this might work. Imagine if you had 2 quarters. Well, that would be the same as 50 cents or having 5 dimes. 1, 2, 3, 4, 5. In another situation, in a different pocket or something, we might have, let me change my color. We might have, let's see, a dime and a nickel, which would be 15 cents. So I might have a nickel, and a nickel. Those are all the same. Now, if I were to combine these, add them all together into my total pockets, I can do the quarter and the dime and the nickel. Quarter, dime, and nickel in one pocket. That's 50 cents, and another 15 would make 65 cents. 65 cents. On the other side, I'd still have 5 dimes and 3 nickels. Well, again, that's 50 cents, another 15, 65 cents. So it's okay to take one type of equation and another equation and add them together because they both remain equal. That equality didn't change when you combine the two. That's what we're going to be doing here today with 2 equations. Let me get to a new page. All right. We're going to do 2 examples. The first one will be 4x plus 8y equals negative 24. And the second equation is negative 4x plus y equals 33. Now you can see with these 2 equations, they don't say y equals. I don't know one equation is equal to y, the other equation is equal to y, therefore they would be the same or equal to each other. But now these are in standard form. Looking of the type where it says ax plus by equals c. Number times x plus number times y equals c. What we're going to do here instead is try to add them together like we did with our money. So if we were to add these together, 4x minus 4x, that would cancel and make 0 x's. 8y plus 1 more y would make 9y. And on the other side, negative 24 plus 33, I believe, would make 9. Now 0 x's, I don't have any x's, so I can ignore those. I just have 9 y's that are going to equal 9. Solve for y, divide by 9, and I get y equals 1. So I know these 2 equations will have some point where y equals 1 on them. And now I want to find the x number that would correspond. I can substitute or plug the y back in to my equation and find out what the x should be. I'm going to do it for both. 4x plus 8y, but the y is a 1, equals negative 24. And my second situation, negative 4x plus 1y, which was 1, plus 1 equals 33. Solve them. Let's see. 8 times 1 is 8, so I can subtract 8 on both sides. 24 minus 8 would give me negative 32, and 4x remaining, divide by 4, x equals negative 8. Check with your other equation. Add 1 to both sides, or subtract 1 on both sides, 32. Negative 4x equals 32, divide by negative 4, x equals negative 8. Perfect, I got negative 8 for both. Now I know for sure, I've checked my answer, my solution was true. So again, we want to write this as a point. Where will these 2 equations be the same, intersecting on my graph in standard form? It would be at when the x was negative 8 and the y was a 1. Let's look at one more example. In our last example, this one's going to be a little bit different because we're going to have an equation x plus y equals 16, and the second equation 4x plus 8y equals 76. If I tried to simply add these together right now, I'd get 4x plus another x would be 5x plus y and 8y, 9y, and, oh goodness, I want to say 92. Well, I still have an x and a y. Nothing was eliminated. That's the goal of this method, elimination, to cancel out one of the variables. So that method, that did not work. Let's erase that. So before I can add, I'm going to have to use a scale factor to kind of make one of these equations larger. So I'm going to choose to take my first equation and multiply the entire thing by -4. And you'll see why in a moment. If this whole thing gets multiplied by -4, I will have -4x plus -4y equals -64. And my second equation is not going to change. 4x plus 8y equals 76. Now if I add them together, -4x and +4x makes 0x. Something got eliminated. That was the goal. Continuing, -4y plus 8y would be 4y's. That didn't right. 4y equals 76 and -64. I'm going to say that's 12. Solve for y, divide by 4, y equals 3. Plug it back into your original equations and check that it was correct. X plus y, so the y is a 3, equals 16. Well, I know what the x should be there. If I say 13. 13 plus 3 equals 3. Check the second equation. 4x plus 8 times 3 equals 76. 8 times 3 would make 24. Subtract 24 on both sides. 4x equals, ooh, this is tough math in my head, 52. Divide by 4, and we still get x equals 13. Perfect. So these 2 points are going to intersect on my graph at the point where x is 13 and y is 3. Now I did not have to choose -4 as my multiplier. I could have chosen to take my first equation and instead multiply it by -8. If I did that, I would have had -8x plus -8y equals, I am not sure, -16 times -8. However, my handy dandy calculator told me it is 128. And then my second equation remains the same. 4x plus 8y equals 76. Now if I were to add them together again, nope, that should be -28. -8x plus 4x would be -4x. -8y plus 8y, that cancels out and makes my 0y's. That's what I was hoping for. And then -128 plus 76 would give me 52. Solve for the x, so I've got -4x equals 52. Divide by -4, divide by -4. X equals -13. Oh, this is negative, positive. There we go. X equals 13. Same answer as I got before. I would then plug this back into my original, 13 for the x, plus a y equals 16, and solve for my y, which is still 3, and I end up with the same answer. It did not matter whether I chose to eliminate the x variable by multiplying by -4, or if I chose to eliminate the y variable by multiplying with this -8. Both methods solved my system.